Yo, what's good? Welcome back to another episode of How to Algebra. Today we're kicking it up a notch with arithmetic series. Think of them as the sum of an arithmetic sequence. Hopefully you've caught the last video. And in this video, we're going to uncover the formula to find that sum. Whether you're adding up of the first few terms or a whole bunch of terms, or even all the terms in the series. So get your thinking caps on and let's get ready to master arithmetic series like a pro. Let's get it. All right, so arithmetic series. If you recall, an arithmetic sequence is a list of numbers that have the same common difference from one term to the next term. All right, what an arithmetic series is it takes the sequence and instead of just listing out the numbers, we are adding up the numbers. So you're either adding, so instead of 4, 6, 8, 10, all the way up to whatever number, it's 4 plus 6 plus 8 plus 10. So it's adding up the first n terms of the series, which the first nth term, right? Like the first 5 terms or the first 4 terms, whatever the case is, we consider that to be the partial sum. And then if you add up the entire series, well, then that's just the sum. So we're going to look at some examples of this. And then in the end, we're going to have a nice formula because we love formulas, right? And we're going to come up with a formula that will work pretty much regardless of what the series is. Well, I take that back. It has to be an arithmetic series where each term is a common difference away from the previous term. So arithmetic sequence, regardless of the arithmetic sequence, we can add up the numbers, add up the terms. So let's consider the sequence again. I think we had this last time. 4, 6, 8, 10, 12, 14, 16, 18. So it's finite, right? There's only so many terms. There's no ... right? It's a short list. 8 terms. There's 8 terms. Okay. So if I want to find, so let's talk about some notation real quick. So S sub n, this is saying to add up the first n terms, whatever n is, right? Like say if it's like for instance in number 1, letter A, we're saying S sub 4. So this is saying to add up the first 4 terms. Okay, so that would be the first 4. So 4 plus 6 plus 8 plus 10. So just doing some quick, brute force math. 4 plus 6 is 10, plus 8 is 18, plus 10 would be 28. So the first 4 terms of this arithmetic sequence would be 28. All right, what would the first 5 terms add up to? So this would be 4 plus 6 plus 8 plus 10 plus 12. So 28 plus 12 essentially. So this is going to be 40. All right, and then the first 8 terms, feel free to work ahead. 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18. All right, so it's going to be 40 plus 14, so 54, 64, 70, 88. So if you add up the first 8 terms, there's only 8 terms, but if you add up the first 8, you would get 88. Now, notice we added them up manually, like one by one, and then, but let's just say it wasn't just 8 terms. What if it was 100 terms and you wanted to figure out what do all 100 add up to? Well, then you would definitely not want to add up every single one. I mean, you could, but you know, why would you? But we'll get to that in a second. All right. I guess answering some of these concept type questions, right? So, okay, so how does A1 plus A sub 1 plus A sub 8 compare to A sub 2 plus A sub 7, A sub 3 plus A sub 6? And all right, so basically we're adding up. So A1 and A8, so that would be 22. So the second term and the seventh term, so 6 and 16, it's also 22. The third term and the sixth term, 8 and 14, 22. And then the two middle terms, so 10 and 12, oh, so 22. All right, so it's kind of a coincidence. You know, it's not exactly a coincidence, but you know, it's interesting that when you add up the n numbers or these particular pairs, we get the same value, 22. It's kind of interesting. That's going to play a role here in a second. All right, so let's explain how to find A sub 8. So how can we figure out the sum of all 8 by using the fact that the first and the last is 22? All right, so this question isn't as obvious, but if you think about it, right, like in a progression of questions, if we look at the last question, so we can take 22 and then multiply it by 4, right? 4 times 22 gives us 88, which is kind of interesting. So the sum of all 8 numbers, so I guess right now we're kind of like we're deriving a formula right now, actually. So we have 8 terms, and somehow when you add up the pairs, that they make this value, in this case 22. And then it turns out that we had 4 pairs because there were 8 terms. So 4 times 22, because each pair added up to 22. So it was the number of pairs times the value of the pairs, right? 4 times 22. All right, so that's going to play a role here in a second. So it was the number of pairs, right? So because it says to explain, not necessarily show. We haven't explained anything. So it's so the number of pairs times what? Times the sum of the pairs. I guess that's one way to say it, of the pairs. Particularly the first and the last one. As long as it's an arithmetic sequence, then like the pattern should be the same, right? Okay, so consider the arithmetic series 1 plus 2 plus 3. So this is the first 100 numbers in the natural number set, right? 1 to 100. If I add up every number from 1 to 100, 1 plus 2 plus 3 plus 4, all the way up to 100. All right, how many terms are there in this series? There's 100 terms. There's 100 terms. Okay, taking the idea from the previous problem, right? If all the terms in the series are paired up, like the picture here, how many pairs will there be? Well, there's 100 terms and everyone has a pair, so it would be 50 pairs. So there'd be 50 pairs, right? So 1 plus 100 would be 101. Oh, and that's the next one. What is the sum of each pair of numbers? So 1 plus 100 is 101. 2 plus 99, 101. 3 plus 98, 101. So the trend is that the sum of each pair would be 101. 101. All right, so find the sum of the series. Explain how you arrived at the sum. Okay, so going back to the previous problem, so we took the number of pairs, 4, times whatever each pair, like the sum of each pair. So 4 times 22. So here, in this particular problem, if we do the exact same thing, right? We take the number of pairs and we multiply it by the sum of each pair. This should give us the sum of the series, right? So there's 50 pairs times 101. So what would that be? I don't got a calculator. $50, 5,050. Is that true? It's true. All right, so the sum would be 5,550. And again, we took the number of pairs, which was 50, and then we multiplied it by the sum of each pair. In this case, 101. All right. So in general, so now notice real quick, right? So this was an arithmetic sequence series because each number is one number larger than the previous number. So it's arithmetic, right? Like the common difference is 1. So because it was arithmetic, this process that I'm showing you works. So now in general, any arithmetic sequence would look like this. A sub 1 plus A sub 2 plus A sub 3 all the way up to A sub n, some number. All right. Write an expression for the number of pairs of terms in the series. So number of pairs. So the number of pairs depends on how many terms there are. So it would be the number of terms divided by 2. So in general, if n represents the number of terms, then n divided by 2 will give us the number of pairs. Right, so like in case of the last example, if there was 100, if there was 100 terms, right, 1 plus 2 plus 3 all the way up to 100, if there's 100 terms, then that would make 100 divided by 2, which would be 50 pairs, right? So n divided by 2, that's the number of pairs. So if we continue with the train of thought that we're having, right, here we had a very specific example. If we do the same thing, but in general, well, then the sum for n terms would be the number of pairs times, what you think? A sub 1 plus A sub n. And that really doesn't matter, or A sub 1 plus A sub n, like it, no matter what pair you pick, they're going to add up to the same number. So A sub 1 plus A sub n is just as good as any. All right, so this right here is a very important formula. because this tells you the sum of the first n terms. All you need is the first term, the last term, and the number of pairs. So let's see if we can apply this. So using the formula from the previous problem, so we're going to use the red box formula to find each partial sum of the arithmetic sequence 4, 6, 8, 10, 12, 14, 16, 18. Okay, so I guess we like this set of numbers. Compare your results to answer in question 1. Oh, okay, I see what's happening. All right, so again, we want to add up the first 4 numbers. So 1, 2, 3, 4. Now, I'm not going to add them up manually like we did in the beginning. I'm going to use the formula. So S sub 4, so here n is equal to 4 because we want the first 4 terms. So this is going to be, so if n is 4 divided by 2 times a sub 1, which is the first term, plus the last term of the set that I want to add up, right, which would be 10. So this would be 4 divided by 2 is 2 times 4 plus 10 is 14. So that's going to be 28. We'll compare in a second, or you could pause and look right now. All right. B, sum of the first 5. So n is equal to 5. Therefore, the sum of the first 5 terms is going to be 5 divided by 2. The first term is 4. Here, the fifth term, right, a sub n, a sub 5, the fifth term is going to be 12. So this is 5 over 2 times 4 plus 12, 16, which is going to be, so 8. So 5 times 4 is 40. All right. Moving right along. N is equal to 8. So the sum of the first 8 terms is going to be, so 8 divided by 2 times a sub 1. So the first term, 4, and then the 8th term. So 4, 5, 6, 7, 8. So plus 18 is equal to, so 8 divided by 2 is 4. And then 4 plus 18 is 22. And this is going to be 88. So now, 28, 40, and 88. If we compare to questions 1, A, B, and C, 28, 40, and 88. So we notice that they're exactly the same. So the formula for the partial sum is clutch, right? It's clutch. You can add up any n terms for any arithmetic sequence. It's very useful. It's very powerful. All right. It gets even more dope because that same formula has a second form, which is okay, so I know that it for sure looks intimidating. 100%. Like, I get it. But what's happening is that if you were following the last, or if you watched the last video on arithmetic sequences, the formula for an arithmetic sequence, so a sub n any term, would be a sub 1 plus n minus 1 times the common difference. So the way we apply that, so if we kind of combine the last formula from up above, so S sub n, right, the sum of the first n terms is n over 2, a sub 1, which is the first term in a series, plus a sub n. But if we use the definition for a sub n from sequences, right, I'm just going to apply this here. This is going to be a sub 1 plus n minus 1 times the common difference. So now notice, combining the like terms, n over 2, a sub 1 plus a sub 1, oh, that's just 2a sub 1 plus n minus 1 d. All right, now you won't have to do this every time because you're just going to have the go-to, right? You're like, it's already going to be ready for you. You don't have to derive the formula every time. But I'm just showing you where the formula kind of comes from. It's from combining the two definitions, right? So with that being said, if we look at A, so here we have 3 plus 8 plus 13 plus 18 plus ... right? Like the list goes on and on. We don't know when it stops. But we do want to add up the first 20 of these terms, assuming that it's arithmetic and that the pattern continues. So what do we need to know? We need to know the first term, a sub 1, which is 3. We need to know that n is equal to 20 because we want to add up the first 20. And then the common difference. So what is the difference from one term to the next? So from 3 to 8, we added 5. From 8 to 13, we're adding 5. 13 to 18, we're adding 5. So it's safe to say that the common difference is 5. So taking these three figures, a sub 1, n, and d, or 3, 20, and 5 respectively, and plugging them into the formula. So let's just apply that. So this would be 20 over 2 times 2 times a sub 1. In this case, a sub 1 is 3, plus n, which is 20, minus 1, times the difference, which is 5. Okay, this is where you have to be on it. Like you got to be nice when it comes to PEMDAS, right? Like you got to be able to add and subtract and multiply accordingly. So 20 divided by 2 is 10. 2 times 3 is 6. Plus 20 minus 1 is 19 times 5. All right, so think about this for a second. 19 times 5. 5 times 9 is 45. Carry the 4. 5 plus 4 is 9. So 95. All right, 6 plus 95 is going to be 101. And then 10 times 101 would be 1010. So you have an arithmetic series, 3 plus 8 plus 13 plus 18 plus ... If the pattern continues, if you take the first 20 terms and you add them all up, you get 1010. That's kind of cool. That's kind of cool. All right, looking at B, the last one, same idea, right? A sub 1 is going to be negative 2. And notice this one's slightly different. There's minus signs. So we're actually going in a different direction. We're going down. So n is equal to 18 because we want to know the sum of the first 18 terms. And the common difference is going to be, what do you think? Negative 2. Right? Because negative 2 minus 2 is negative 4. Minus 2, 6. Minus 2, 8. Minus 2, so on and so forth. All right. Switch colors. So let's do it in red. All right. So this would be, so here we have S, sum of the first 18 terms. So n is 18. So 18 divided by 2 times 2 times the first term, which would be negative 2, plus n minus 1. So 18 minus 1 times the common difference of negative 2. All right, simplifying. Sum of the first 18 terms is going to be 9 times negative 4 plus 17 times negative 2. All right, 17 times negative 2 is going to be negative 34. Is that true? 7 times 7, no, it should be a 9. Oh, no, we're not squaring it. I stand corrected. 34, negative 34. So this is going to be 9 times negative 38, which is 9 times 8 is going to be 72. Carry the 7. 9 times 3 is 27. Plus 7, 34. So negative 342, right? If we kept this going, right? Negative minus 8, minus 10, minus 12, minus 14, so on and so forth. If we take the first 18 terms and then add them all up, combine them, it would be negative 342. Okay, I think that sums it up. Haha. All right. Catch you guys in the next video.